Wireless networks are a crucial part of our everyday lives, but what many don't realize is the critical role site surveys play in ensuring their seamless operation. As we delve into the world of wireless network design, we come across the concept of site surveys. But what exactly is a site survey and why is it so important? Imagine you're setting up a wireless network in a new office. You have the latest equipment and a team of experts ready to go. But where should you place your access points? How can you ensure that every corner of your office gets a strong signal? This is where a site survey comes in. It's a process of studying the proposed site to determine the best locations for access points, taking into account the layout, the construction materials, and the presence of any potential sources of interference. A well-conducted site survey helps avoid signal interference that can degrade network performance. It identifies potential obstacles such as walls or equipment that can block or reflect signals, causing dead zones where the wireless signal is weak or non-existent. By identifying these obstacles ahead of time, you can plan your network layout to overcome them, ensuring a strong, consistent signal throughout the site. Moreover, a site survey also plays a critical role in ensuring optimal network performance. It helps in determining the number of access points required and their ideal placement for maximum coverage. It also aids in identifying the right wireless channels to use, avoiding overlaps that can cause interference and degrade network performance. But perhaps the most significant contribution of a site survey is its role in future-proofing your network. By taking into account future growth and changes in your organization, a site survey helps create a flexible network design that can adapt to your changing needs, saving you time and resources in the long run. To sum it up, a site survey is more than just a preliminary step in wireless network design. It's a vital component that helps ensure your network is robust, efficient, and capable of meeting your organization's needs both now and in the future. So, a comprehensive site survey is an essential first step in designing an efficient and effective wireless network. Now that we understand the importance of site surveys, it's time to delve into how to conduct one. The first step in conducting a wireless site survey is planning and preparation. This is a crucial stage that sets the foundation for the entire survey. Begin by gathering information about the site. This includes understanding the physical layout of the building, the construction materials used, and any potential obstacles that could interfere with wireless signals. Next, define the scope of the survey. What areas need coverage? What are the intended uses of the network? This will help guide your survey and focus your efforts. Once you have a clear understanding of the site and the goals of the network, it's time to move on to the physical survey. This involves walking around the site with a wireless analyzer to measure signal strength, noise levels, and interference. Remember, the key to a successful physical survey is thoroughness. Make sure to cover all areas of the site, including corners and potential dead zones. But don't rush this step. Take your time to get accurate readings. Following the physical survey is data collection. This step involves recording the findings from your physical survey. This could include signal strength at various locations, potential sources of interference, and areas of weak coverage. It's important to be meticulous during this stage. The more detailed your data, the more effective your wireless network design will be. The final step in conducting a wireless site survey is analysis. This is where you'll take all the information you've gathered and use it to design your wireless network. Analyze the data, looking for patterns and potential issues. For example, if there's a particular area where signal strength is consistently low, you may need to add additional access points in that location. Or if there's a source of interference, like a microwave or cordless phone, you'll need to take steps to mitigate its impact. In this analysis stage, it's also important to consider the intended uses of the network. For instance, if the network will be used for video conferencing, you'll need to ensure there's sufficient bandwidth and signal strength to support this. Conducting a wireless site survey may seem like a daunting task, but with proper planning and careful execution, it can be a smooth process. And it's a critical step in ensuring your wireless network is designed to meet your needs and perform optimally. By following these steps, you can ensure a comprehensive site survey that will lay the groundwork for a successful wireless network design. Despite the best planning and design, wireless networks can still face issues. Let's explore how to troubleshoot some common problems. Firstly, let's tackle connectivity problems. These can be due to a range of reasons, from simple device misconfigurations to more complex network problems. Begin by checking the device's wireless settings. Ensure that the correct network is selected and that the security credentials are accurate. If the issue persists, try connecting another device to the network to isolate the problem. If multiple devices are struggling to connect, it's time to look at the wireless router or access point. Check if the device is powered on and functioning correctly. Restarting the device can often resolve connectivity issues. If not, you may need to delve deeper into the configuration settings or even consider a firmware update. Next, let's discuss slow speed issues. A common culprit is signal interference. This can come from other wireless networks, electronic devices, or physical obstacles. To identify this, use a wireless analyzer tool to scan the wireless environment. If you detect high interference, consider changing the wireless channel or moving the router to a less congested location. But interference isn't the only cause of slow speeds. The problem could also be network congestion. If too many devices are connected to a single access point, it can slow down the network performance. In such cases, consider adding more access points or setting up a wireless mesh network to evenly distribute the load. Now, onto signal drops. These can be particularly frustrating as they can occur unexpectedly and disrupt ongoing activities. Again, start by checking for signal interference or network congestion. However, if these aren't the issue, it could be due to the wireless device moving out of range or the access point being overloaded. To counter this, consider installing additional access points for wider coverage or limiting the number of devices connected to a single point. Remember, troubleshooting is a process of elimination. Start with the simplest solutions and work your way towards more complex ones. And always keep in mind that every wireless environment is unique. What works in one scenario may not work in another. Lastly, don't forget about the importance of regular network performance testing. Regular tests can help identify potential issues before they become significant problems. Use network monitoring tools to keep an eye on your wireless environment and act swiftly when issues arise. Armed with these troubleshooting tips, you can swiftly address any issues and maintain an efficient wireless network. As we wrap up this episode, let's revisit the key points we've covered today. We began our journey by discussing the crucial role of site surveys in the design of wireless networks. Site surveys are not just a good to have, they're an essential part of the planning process for any wireless network. They help us understand the physical and RF environment where the network will operate, and they provide valuable insights that can inform the design of the network. This includes determining the optimal locations for access points, understanding potential sources of interference, and predicting the range and strength of wireless signals. Next, we delved into the process of conducting a wireless site survey. It's not just about walking around with a signal meter, but involves a systematic and comprehensive evaluation of the site. This includes gathering requirements, visual inspection of the site, testing and measuring RF signals, and finally, analyzing the data and preparing a detailed report. Each step is critical, and skipping one could lead to suboptimal performance or even failure of the wireless network. Then we shifted gears to talk about troubleshooting common wireless issues. We all know that even the best designed networks can encounter problems. The key to resolving them quickly and effectively lies in understanding the root cause. This could be anything from signal interference, poor signal strength, to hardware or software issues. And remember, troubleshooting is not a one-time process, but an ongoing activity that helps keep your network performing at its best. In essence, a successful wireless network design is a blend of these three aspects. A thorough site survey sets the stage for a robust design. A systematic process ensures the survey is done right, and effective troubleshooting ensures that the network continues to meet its performance goals even when problems arise. Remember, a well-conducted site survey and effective troubleshooting are the backbone of any successful wireless network. Until next time, keep exploring and keep learning.